Welcome to this lesson on simple linear regression. Simple linear regression is used to estimate the relationship between two quantitative or numeric variables, salary and years of experience, for example. Salary is a dependent variable and years of experience is the independent variable. Regression models are equations and graphs that describe the relationship between variables. Linear regression models use straight lines, nonlinear models use curved lines. Regression allows us to estimate or predict how a dependent variable changes as the independent variable changes. Linear regression relies on several assumptions, the first being linearity. The relationship between the independent variable, years of experience, and the dependent variable, income, is linear. Violations could occur when there's a nonlinear relationship. So, for example, quadratic or exponential relationships may exist between years of experience and income. An example, practically, is if initially income may increase linearly with experience, but then plateau or increase more slowly over time. Independence of the errors is another assumption of linear regression. Possible violation is when there's autocorrelation in the residuals, where the error terms are correlated with each other. A practical example of that is if income tends to increase more consistently over time due to external economic factors, the errors might then be correlated. Homoscedasticity. The variance of the residuals is constant across all levels of the independent variable. That's another assumption. Violation would be heteroscedasticity, where the variance of residuals change as the independent variable years of experience changes. Example of this practically would be if we have younger individuals with less experience having more variation in their income versus those who are older and have more income compared to their individuals with more experience. So basically, more variation in younger individuals, less variation in older individuals with regards to income and education, or income and experience. Normality of residuals is another assumption. Violation will be if you have non-normal errors or residuals, and that might occur if income distribution is heavily skewed or if there are outliers in the data. No multicollinearity. This is a situation that happens when we have more than one independent variable, so multiple regression as opposed to simple linear regression. This could happen if we had a situation like we have years of experience and education level as our independent variables, and they happen to be highly related or highly correlated. This can lead to unstable coefficient estimates and difficulties in interpreting the effect of the individual predictors. No outliers. Again, it's another situation where we try to keep the outliers out of the data because that can influence the regression results. If you have any of these assumptions that are violated, then you can do transformations on the data to make them more in line with these assumptions. And so, yeah, that's it. For the simple linear regression equation, it is y is equal to beta 0 plus beta 1 times x plus epsilon. Here, beta 0 is the intercept or the y-intercept, a constant of the regression line. Beta 1 is the slope or the weight that's being multiplied by x, which is our income, or our input variable, which is our years of experience, and y will be our resulting income. Epsilon is the error term that represents the difference between the actual response from the predict versus what we predict. So that is that's that. The steps to perform simple linear regression: we're going to calculate the means, and that's the average input and average output, or the average years of experience and average income. And we're going to use the x's and those averages to calculate the slope using the equation here for beta 1, and we'll calculate the intercept using the average income minus beta 1 times the average years of experience.